Good day, ladies and gentlemen. Thank you for standing by, and welcome to the Crack Sealing webinar. At this time, all participants are in a listen-only mode. Later, we will conduct a question-and-answer session. Instructions will be given at that time. If you should require any assistance during the call, please press star then 0. Thank you. I would now like to turn the call over to your host, Jason Dietz. Please go ahead.
Thank you, Chief. Well, welcome, everybody, and thank you for joining us today. My name is Jason Dietz, and I'm with the Federal Highway Resource Center and partnering with the Pavement Preservation and Recycling Alliance today on a series of pavement preservation webinars focusing on pavement preservation. Today's webinar will focus on crack sealing, Series 2, with a focus on equipment and proper installation. You will see a number of polls on the screen. We ask you to take a moment to answer those, and we will close them in just a minute as the presentation will begin. We also encourage questions during the webinar and ask you to please take the time to respond to the evaluations at the end of the webinar. All attendees are on mute, but you can submit your questions through the chat function on your screen, and we will answer those as time permits. We're also offering PDHs for today's webinar on request, so please let us know after the webinar if you would like to receive those. I'd now like to introduce today's speaker, Brian Darling. Brian Darling has been with Craftville since 2000 and currently serves as the Western Regional Manager. His responsibilities include leading the 14 states and all employees in his territory across the west and midwestern parts of the United States. He is an active member of associations such as APWA and the National Association of County Engineers, Maintenance Superintendents Association, and the International Slurry Association, where he serves as the chairman of the Crack Seal Committee. Brian, on behalf of myself and PPRA, we want to thank you for your time today, and I will now go ahead and pass it over to you. Brian.
Thank you, Jason. Welcome, everybody. I want to take a second just to say thanks for joining us for this presentation. I also want to let everybody know that we will be emailing out these presentations and the videos. We have a lot of people on the line here and a lot of videos, so we're going to email those out, so you will be getting those by email. So first up, we've got a polling question. Just wanted to ask who we have with us today, either being contractors or if we've got some academia people or engineers with us. So if you could take a second and answer that just so we have an idea of who all we have with us today, that would be great. Give that a couple seconds here to go through and see who we've got. Yeah, looks like we're getting up there. Looks like we've got a good selection of people here, so that's great. Give it just a second more, and then we'll go ahead and close that out, and we'll kind of get started here. So our agenda, we're going to be talking a lot about equipment and best practices, preparation, doing reservoir cutting, proper sealant, heating, maintaining the melter temperature, equipment, application configurations, finishing, and then we'll close it up with personnel and traffic control and some of the things we need to be doing. And these are all going to be steps that are necessary to accomplish a good quality application, which is what we want. Appropriate sealant, appropriate application are some of the two most important parts of a good, effective crack sealing program. Can't state it enough, the cracks always need to be clean and dry, and that's really a big part of this. And then pavement temperature and condition. We want to look at that too and just make sure we're doing the right thing. Structurally sound pavement is also very critical. If we're not sealing in a structurally sound piece of asphalt, our sealant's not going to stay in that asphalt. So we want to make sure we're working on the right roads at the right time. And then again, just the clean and dry aspect of this is very important. When we talk about structurally sound pavement, we want to make sure that our surface that we're bonding to is intact. It's a good, strong surface with no rattling and no loose aggregates. What's going to happen is that sealant is going to stick to the first thing that it comes to in that joint or on that surface. And if we don't have a good surface there, we're going to just adhere to loose asphalt or rattling asphalt, and it's not going to stay in, so that doesn't do us any good. So making sure we've got the right surface that we're trying to seal is very important. So that brings us to our next polling question. What type of climate do you work in? Cold, hot, or rainy and wet type of climate? So we'll give that a second for everybody to answer that. Looks like we're getting good response here. A little bit of mix of hot and cold type weather, so that's good. We can address some of those things. We'll give it just a second more here. Go ahead and ready to close this one out. Okay, we got good response there. So talk about making sure that the pavement is dry. Again, that's very critical. We do see dampness in areas where we have moisture coming in from either frost or dew in the morning. We also see it when the dew point gets down below the temperature, or the temperature gets below the dew point, and that will bring in moisture. So making sure that that is not a factor is very critical when we start doing the crack sealing operation. And we'll talk a little bit more on how we can work with that and deal with that. So the weather conditions, ideal conditions is a moderate to warm condition, little to no wind. Generally the spring and fall are the best times to do the crack sealing. The asphalt's going to be a little more relaxed. The cracks that are there are going to be partially open, and that really makes it a great opportunity to get the sealant down in those cracks and make sure we're filling that void and sealing that up. Wind can be an issue if we start to get real windy or cold. Ideally, we like to see the temperature 35 to 40 degrees and rising. A hot air lance can be used in cooler areas or in an area where maybe you've got trees. We'll see that sometimes in rural areas around a curve where you've got trees overhanging the pavement, and the pavement's not warming up because it's got no sunshine on it. Definitely use a heat lance on that to warm that back up. Or if you've had rain the day before and you've got to get out and do some crack sealing, we'll talk a little bit more about things to look at with that and how we can use a heat lance to help you keep your crack sealing program going. The other part of this is making sure the cracks are good and clean. If we're not good and clean, the sealant is going to stick to that dirt or debris that's in that crack immediately, so we're not going to get good adhesion. So making sure that we have a good clean crack is very important. As you can see on the photo on the left, that crack has a lot of dirt down inside of it, and even some dirt on the surface of the asphalt. Whereas the crack on the right side, that photo there, that's been cleaned, vacuumed out, very clean down inside the crack and on the surface. So if you're doing an overband, you're really helping your overband adhesion also, and that would make a good candidate to seal. Several different ways to do cleaning on a crack. One of the most widely used is just a compressed air with a blow-on. We also see a vacuum with combination of the vacuum and compressed air, heat lamps, and a wire brush. So we're going to go over a couple of these and kind of show you how these can be done. So when using a air compressor with just a blow-on, again, this is probably one of the most popular ways to clean out your cracks. You're going to have a gentleman out front cleaning, getting the debris and the dirt out of the cracks. Want to make sure that whenever you're in an area with traffic that they're blowing the dirt and debris away from the traffic and the co-workers, and making sure that the operator is staying within the control lane during the clean. You want to make sure that your air compressor is giving us at least 90 psi on the pressure. That way we know we're getting enough pressure to dislodge any of the dirt and the debris down in those cracks. And next here we got a video. See if we can get this to play. Let's see, I'm not sure we've got, if we're going to get this to play or not. Like it's trying to, so hopefully, there we go. So as you can see here, a lot of dirt that they're blowing off. He's also making sure that the asphalt on the top around the crack is good and clean, and making sure all the dirt down in the crack has been blown out. This will make sure, again, that this gives us the best chance to get the most performance out of our crack sealing job. All right. So when it comes to compressors, we have several different options of compressors that can be used. A lot of compressors are built right onto the machines, or they can be a tow behind or a compressor that's mounted up on the truck. We want to make sure that the compressor has a oil and water trap hooked onto the air line. That way, as the compressor runs, it will generate a little bit of water or moisture, and also could see some oil being pushed through the airline. So with that trap on there, we're making sure that we're not pushing that into the crack that we're trying to clean out. And then that way we're making sure that we get the best cleaning and making sure that our adhesion of the sealant is as good as we can get it. Of course, as normal, you would want to make sure that you're checking the oil and air filters daily on your compressor, whether it's on a machine or if it's on your truck, and then checking the fluids just to make sure that it stays at top running condition as you're working through your project. One of the other ways to clean out the crack is a vacuum system. These systems can be either mounted on the back of your truck that tows the crack seal machine, or trailer mounted and out working in front of the crack seal crew. Generally, vacuums are used in areas where they are very sensitive to air quality. These vacuums can get down to 10 microns of dirt, so they'll meet the PM10 restrictions in some of the areas. Some of the other advantages to using a vacuum system like this is you're not blowing dust and dirt all over the work area that has to be cleaned up after the fact. It also keeps a cleaner work environment for your workers. So there are some other advantages to using a vacuum system. Most vacuum systems, like this one, has a wand that you would run around on the asphalt. This one is set up where it has air injectors mounted in the front of the vacuum head. This is going to inject air down into the crack, digging the dirt out, and then there's a vacuum hose that runs up along the handle that pulls the dirt and debris up into the vacuum system itself, where it is filtered out through some couple of different filter systems and then returned back into the atmosphere. And we've got a little video here. We will get started. This one brought up for you. This one's going to show just a short clip of the vacuum head being used. There we go. So the vacuum head just runs right along the asphalt and the crack. And a little jumpy here, but you can see how it's pulling the dirt out, and then you can also see around the top of the edges of the crack how it has cleaned the surface of the asphalt also, and that's allowing, again, the sealant to seal to the surface and down inside the joint itself. So again, just a great way to clean the cracks out without creating a mess and putting a lot of dirt and air into the environment. Let's switch back over here. Next up, we have the heat lamps, and again, this would be used in an area where you've got to remove a little bit of moisture and warm up your pavement. It will blow out some of the dirt and debris and burn out the weeds. It works very well, again, for moist climates. If you're doing nighttime type crack sealing, again, where the temperature is starting to drop below the dew point, this is where you would want to use a heat lamps and make sure that you're getting that dried out. I will tell you, though, if you're in an area where you've got a lot of rain, if it's raining or the pavement is very saturated with water, you will not be able to get it dried out enough to do the crack sealing you'd like to do. So it won't do that if it's got a lot of water, standing water, or just the asphalt's very saturated. So it does have a little bit of limitation to that. Some of the things we want to make sure we watch when we're using the heat lamps is the darkening of the pavement. You want it to start just to darken it a little, but you don't want to get it smoking, because at that point, that's an indication that you're starting to scorch the asphalt, and you're going to do more damage than good at that point. You should always kind of keep the heat lamps moving over the crack and keep that whole operation moving. You do also want to make sure that when you're using the heat lamps that you follow immediately with your crack sealing operation, because what will happen is the moisture and the dew will start to creep right back into the crack that you've heated up. So you need to make sure that you get that sealed immediately. And then also as they're sealing it, if they start to see bubbling in the sealant, that is normally an indication that the pavement needs to be dried out a little bit more to a greater degree. If they cannot get it dried out well enough, then we probably would have to suspend crack sealing for the day and wait until it dries out a little bit more naturally. Then one of the last ways we see cleaning done is with a gas-powered wire brush system. This will work in an area if you've got a lot of wide cracks that have a lot of dirt that's really packed in and a vacuum or a blow stick cannot get it dug out. Then this would be your next step, would be to wire brush it and get in there and just run that down inside those wider cracks, digging out the dirt. Still may have to come back in with a glow stick or a vacuum and clean that the rest of the way out, but this will help to get the impacted dirt and debris out of those cracks. And this is just a quick picture kind of showing what happens with improper cleaning. You can see that the sealant just peeled right back up here. It was over the crack and it left a little bit of a discoloration where it tried sticking, but there was too much dirt there and it just allowed it to come right back up. So this is what we want to avoid as we're going through our project. Now I want to talk a little bit about reservoir cutting or routing. This is a very good solution to dealing with cracks that are in high movement type areas, normally cooler areas where you get thermal cracking, which will show up transversely across the roadway. And this would be taking a mechanical router and cutting a reservoir where you have a crack in there. So here on the left side is a picture of a good reservoir. Went down in and cleaned it out very well. On the left side, or excuse me, on the right side, that photo there, you can see that the reservoir was not cut very deep and it started to spall the asphalt a little bit. So that might not have been a good candidate. That asphalt might be a little brittle and it started to spall. So stopping your routing operation would be advised at that point. Production on a router, depending on its conditions, we see somewhere between 1,000 and 2,000 lineal feet an hour. But again, that depends on the amount of cracking, stuff in a given area, and we will talk about crack density here in just a little bit. This is a few pictures of different routers that are out there in the industry. Most routers will follow a meandering crack very well, or a random crack very well. They have depth control, so you can adjust how deep you want the router bit to go down inside there. They have standard flex type routers. There are dust control routers, which will help to meet that TM10 restriction. And then there are self-propelled routers if you're working in an area that has a lot of hills or different slopes to the asphalt. This will help the operator move the router from crack to crack. So next up, we have another question, polling question here. In cold areas, do you route cracks before sealing? So we want to get an idea of who is routing. We'll give that a second to give everybody a chance to answer this one. So it looks like we've got few people that route. We've got some that don't, and some that depends obviously on the situation. So that's good. It's good to see. Give that just a few more seconds, and we'll go ahead and close this poll. Okay. So I want to talk a little more about routing reservoirs. The idea of routing a reservoir is to produce a wider reservoir to get your sealant down inside of that moving crack. And what we want to do is take about 1/8 of an inch off each side of the crack. That way that will give it room for the material, the sealant, to go down inside there. In colder climates, we do see routes that will be made a little bit wider, up to sometimes 3/8 of an inch wide, but then we only see them go about 3/8 of an inch deep. And the idea of that is the more material you get into that material or that reservoir in a colder area that we see a lot more movement in, then that'll allow the material to move better and perform better in that colder area. Again, we do talk about if you start to see excessive spalling, as that bottom picture shows, you can see how it's falling on the edge of the route. It's doing more damage again than what we want to see. So that's when we would stop that type of operation, because you're doing more damage good at that. Blade condition is very key to making sure we're getting good cutting. As always, we would want an operator to be very familiar with the router, read the operation instructions, making sure that the operator is wearing the correct personal protective equipment, gloves, safety goggles, boots, long pants, that kind of thing. We want to make sure that when they're routing, that the router is running up to speed before they lower the grinding head into the asphalt, and then making sure that they're routing over the center of the crack. That way they're taking off an equal distance of asphalt on both sides of the crack. And then one of the real important things is when you're in a traffic area, because the routers, you pull backwards and they will push a little bit sometimes, you want to make sure that you're routing away from the traffic. That way it's not pushing you into any traffic, and you can control your router better that way. When we talk about the router bits themselves, we want to make sure that these are always in good shape, and we're checking them during each break or at lunchtime. As you can see in these photos, the router bits will wear on those top edges. These two routers are set up to cut a little bit wider route. As you can tell on this first picture on the left side of the router, there's only about 4 washers, but on the right-hand side, there's about 6 or 8 washers. So what they're doing is every other router bit, they're offsetting it, so this will get you up to about a 3/4 inch wide route. You look at the picture on the right, that bit is just the opposite, where the more washers are on the left side of the router bit. It's only 4 washers on the right side. But one thing they've also done here is they switched the router blades around so that the rounded edge is on the inside of the cut and the square edge of the bit is on the outside of the cut. That will also help you get more footage out of your blades and a longer lasting blades at that point. And then making sure that we have the right amount of washers and the pins are in good shape so we're not getting a lot of wobble out of the washer bits are definitely will help you improve the amount of footage that you will get out of your router bits, and then also will improve how it cuts on. So we have a video here now of a router running, so we'll get that queued up for you. Give that a second here. There we go. Let's get this one started. In this video, you'll be able to see the operator moving through the different cracks. You know, it's a little jumpy, so it's jumping around a little. Kind of came back. So he was able to follow the crack down the center of the roadway and then over to the edge. The route there that it did. Now again, this is where you would come in and vacuum this up or blow it out to clean out before you put your sealant in. All right, we'll go on to the next slide here. Get that switched back out. So once we get the cracks cleaned out and we get the routing done and cleaned, the next thing we want to address is the proper sealant and the temperature to put the sealant down. As always, we want to make sure we're following the manufacturer's recommendations on that. Most common is 380 to 400 degrees on sealant being put down. I like to see the sealant generally go down on the higher side of its recommended temperature. That will generally allow the sealant to flow better into the cracks. It will also adhere better as it goes down into the cracks, and you will get a better performing crack sealant if you're put down at the higher side of the sealant. Again, overheating the sealant will start to damage it. The sealant starts to burn out some of the asphalt and the oils out of it and can damage the polymers in it. as well as underheating the sealant will result in a limited performance and or complete failure of the product, as it was not heated up enough to adhere and flow into the cracks, stay in place. The proper
Hey, Brian?
Yes.
Sorry to interrupt you. I had a gentleman have a question here, and I thought it'd be a good time. I should have stopped you before you started talking about the sealing and the cracks, but I had a gentleman made a comment about his crew has a hard time following random cracks. And I'm not sure if you've seen that be an issue or not by routing them, but it seems pretty straightforward following the cracks with the router. I'm not sure why it would be hard to follow them.
Well, it is kind of a finesse kind of operation. You know, really, most all routers have some kind of a guide that's down on the drag foot down at the bottom. The biggest thing is you go through a like a curve or turn in a crack. You got to remember, when you see it go underneath the router, it's not cutting for about 6 inches as you go past it. So you kind of have to time how you go into that turn or follow that crack. A lot of times, if you start to feel a little bit of vibration in the crack, you probably come out of vibration in the router, you probably have started to come out of the crack, so you have to kind of pull it back in to where it starts to smooth back out. But it is something you got to take a little bit of practice with, and sometimes not always everybody is really good at it. So you got to find that couple of guys that kind of have the knack for that.
And the other question, Brian, is regarding the cost on some of the vacuum units. Is there much of a cost for the vacuum units for the routers?
Well, for the router, the vacuum system on the router, I believe, and I can only talk to the routers that we manufacture at Craftco, those probably are about a $3,000 to $3,500 difference between a standard router versus a dust control router. So they're a little bit more money.
Thank you, Brian. And one last question. Somebody mentions that they're just getting into crack sealing, and they purchased the Craftco Model 30 routers. From your experience, what brand of router blades are best to use?
Well, we have found, obviously, the blades that we carry are a carbide. Well, we carry a couple different types. The carbide type bits will give you the most footage and give you the cleanest cut when you're routing. So I would definitely recommend a carbide routing bit. And then we do make a wide hub routing bit. I think there was a picture of one of those in there. It gives you a little bit wider hub on there, and it helps keep the wobble out of the router bit. So that will help with getting a cleaner cut and then more footage out of the router bit itself.
And last question, Brian, I'll let you get back to it. Is routing really necessary for a chip seal or seal coat that has aggregate that bridges the crack?
Well, routing is more designed for an area where you've got a lot of thermal movement, and you want to make sure you're getting a reservoir to put down in the sealant down in the asphalt. If you've got just small hairline cracks, and we'll talk about that here shortly, small hairline cracks, and you're going to do a chip seal or another surface application, you may not have to route. This is going to depend on how wide those cracks are, whether you need to route, or even if you need to do crack sealing over it. Because there may be a case If they're just hairline cracks, you may not even need to do any kind of sealing at this time. At some point you will, but maybe this application you may not have to.
Thanks.
Okay.
No more questions.
I'm sorry, what was that, Jason?
No further questions in the chat for now, so
Okay, perfect.
continue.
All right, well, wanted to start talking a little bit about heating the sealant. Again, we want to make sure that we're getting the sealant to temperature when we're getting ready to start the sealing project, always making sure we're following the manufacturer's minimum and maximum on temperature range, and then making sure that during the whole operation that the temperature of the sealant is staying within those, either not getting overheated that could damage it, or being underheated where we're going to lose adhesion. So most of your bigger machines are going to have electronic control boxes that will monitor that through the day, but we just want to make sure we're checking that periodically to make sure we're on the right track. Agitation is also very important with sealant. It helps keep it homogeneously blended. If you have a sealant that has high polymer content, or if you're putting down sealant that has a higher rubber content or even fiber content, making sure the agitation is running all the time, keeping it blended well, and keeping the sealant moving inside the machine itself so we're not overheating out on the outside edges where we're damaging the sealant on the outside there. And then also adding sealant blocks as you're going down through your operation. A good rule of thumb generally, if you're starting with about 3/4 of a tank of material, if you're dropping a block of material about every 5 minutes as you're going through your operation, and then checking to see if you're maintaining a good level of material, or if it's starting to get too high in the tank, you may want to drop back to about every 10 minutes, or vice versa. If it's starting to get a little low, you may want to be dropping more material in, just make sure that machine is keeping up properly. As you can see here, maintaining your temperature is very important. This material here was way overheated and damaged it. It got real thick and gelled it. You'll see getting stringy as it's coming out of the wand. So that's signs of being overheated. If you start to see that with a sealant, you're going to want to stop and get that taken out of your machine as soon as possible. What you'll end up, if you try and use this material, is you're going to have adhesion problems. More than likely, it's going to track or bleed as traffic gets on it, or if you do any kind of other surface application, it'll bleed right through that. So again, following the manufacturer's instructions on heating is very important. We talked a little again about pavement temperature, 40 degrees and rising. Should always be observed. You can see here where this crew is actually crack sealing. There's snow on the ground on the sides of the road, but the road itself is dry, and they're using the heat lamps there right alongside the truck to heat up the cracks, and then they're crack sealing right away. So can you use your heat lamps and keep the operation moving even if you've got snow on the ground, as long as we can get the moisture out and get the pavement up to temperature. Also wanted to touch base a little bit on reheating material. Most manufacturers, you can reheat the materials. We do see some manufacturers that say you should empty the machine out at the end of the day. With craft hose material, we have a pot life of 12 to 15 hours. So sealant can stay in a machine that long as long as it's being agitated. And then you can do one reheat after the initial heat up. But you always want to try and add more material into it because that kind of resets that clock. So you're never ending up overheating or overheating the material if you go past that pot life. Next up, I want to talk a little bit about some of the different melters that are out there. There are different manufacturers across the country, different fuel sources, melt rates, and features that the different manufacturers all have. Everything from small direct fire equipment that would be used in small parking lots to large double pump machines with onboard compressors. So we're going to talk a little bit about those now. So here we have the small direct fire machines, and generally these are used on smaller parking lot type jobs, residential jobs, driveways. They'll have a manual propane burner and manual agitation. So you have to make sure you have somebody attending these machines and staying with the machine all the time. You don't want to leave this machine running all by itself. You also have to make sure that we're using the correct sealant for direct fire, because there's no insulation of a heat transfer oil here. The propane burner heats up the bottom of the steel tank, and the tank itself heats the material up. So you have to have a sealant that is designed for direct fire, or you will end up overheating a standard material and end up with just a blob of material. So that is one critical thing with these small machines you have to be careful with. You get into the bigger machines, these are generally what we would call a double jacketed heat transfer oil machine. So it's going to have heat transfer oil in an inner tank that heats up from the burner and then adds the heat to the inner tank where the sealant is. This way you're not hurting anything. These generally will have automated agitation to keep the material moving inside. These machines will also have a pumping system that will either feed through the back of the machine or out through a hose and wand into the crack. And then these will also have a temperature control system that monitors the sealant, either giving it more heat or setting the heat down as it gets to temperature. These work very well for some small jobs up into the big highway jobs. The top photo here on the left shows a standard valve system. And then the bottom picture there on the left shows a on-demand trigger system. Again, these sizes vary from about 50 gallon all the way up to 400 gallon units. They can be towable units, skid mounted. There are some gravity feed type machines like this small one here on the right hand side. These can either be built in a diesel or propane fired burners. They'll have agitation in them and a small control panel to maintain the heat, but it's a gravity feed where the material would just be poured into a pour pot and then put out onto the asphalt from there. You get into the bigger machines, the hoses can either be a standard heated hose, like we see here on the left-hand side, or an unheated hose that you would heat up. On the right-hand side photo, you can see this one is a unheated hose that you heat manually inside an oven box in the back of the machine. This one also is a double pump, double hose machine. So there's two pumps, two hoses. So this would be used for a very high production type situation, either on a highway or a runway. Generally, these units here, you can cover about 48 feet wide in one pass with two operators on the hose. Here's a little bit more of a close-up picture of the heated hose or heated wands. These here are set up with a trigger system that when you pull the trigger, it will activate the pump and flow the material out of the wand out onto the asphalt. These are generally considered some of the safest machines in the market, as you're not running the risk of running the pump all the time and putting a lot of pressure on the hose going to the wand. Okay, we have another polling question here. Now we're going to talk a little bit about application of sealant. Do you flush fill, squeegee, or disc your application of sealant? So we'll give this a little bit here. Looks like we got a wide range of people that flush fill, squeegee, and disc. Let them finish this up. Looks like it's pretty even across the board there. It's just a few more seconds and we'll finish this up. All right, looks like we're done with this polling question here. So I want to talk a little bit about the different types of wand tips and the squeegees. There's a large variety out there, starting with the sealing shoe. We have the anti-drip tip here. You see the straight tip is used in a lot of wide crack and maybe even in the concrete ceiling where they need to get the material down deep inside the crack. There's also an elongated sealing tip that can be used, or then we get into the flush sealing tip here. A lot of them can use a metal squeegee type tip that has its own squeegee built onto it. And then the swivel disc here at the bottom is very popular on sealing. And then the squeegees are definitely probably one of the highly used pieces of when you're doing a crack sealing job. It's going to let you smooth out and level the sealant. Will let you form a good overband, and then also helps force the sealant down into the cracks of the roadway and clean up a little bit of the messes or maybe drips that are left. The squeegees used for that also. Here's a couple of pictures here. This is actually on the left-hand side. Looks like a straight tip being used, following it up with a squeegee, and then a disc where they're taking the squeegee behind it. And ideally, you don't want your overbands to be more than about an inch beyond each side of the crack. So again, this is where a squeegee comes in very handy to control the size of that overband and the thickness of the material itself. We kind of threw this picture in here talking about is this crack properly sealed? This was a project that was done in October of 2020. Kind of see that they got some sealant in there. They got a lot of material on the surface, as you can see, especially in the photo there on the right-hand side. But there's some issues with it. Probably more material than they needed on the surface, but we've got places where the material had sunk down into the crack, and then we got a good place here where it sealed it up flush with the surface. So ideally, this probably isn't the best sealing that we could do. You would definitely need to come back and top this one off here to fill this back up and make sure it's sealed, or possibly go to a sealant that has a little more viscosity to it so it would hold and not run down into the crack itself. So as you can see there definitely is some things that we can do. We can change up to make sure that we're getting the job done properly. When we talk about application configurations, sealant shape, the reservoir greatly influence the performance in the primary design of consideration. So when we want to maximize the cost effectiveness, we need to definitely look at what we're doing and how we're doing it with the type of sealant and the quality of the application itself. When we talk about the configurations and the different applications, one thing I always like to kind of think about is, what is our next application? Are we going to be doing a slurry or a chip seal or even maybe an overlay? And that will always kind of determine how you want to put your sealant down. Or are we going to just leave this open to traffic for a year before we do anything? So we're going to talk a little bit about some of the different ways we can put sealant down and why we might choose that application over another. So here we have an overband. It's tight to the pavement. The sealant doesn't extend more than an inch past the crack itself. Looks like it was probably put down with a disc. And this would be a very good candidate to leave open to traffic. Got a little bit more sealant on the surface. This will allow the tires themselves to maybe knead that down a little bit. But you can leave this open to traffic until the next season and then come back and do a slurry or chip seal over that and have great success and very high performance for both the crack sealing and the surface treatment that you're going to use. When we talk about the overband configuration, it can be done here with on the left-hand side diagram. This was a squeegee that was used. So they squeegeed it out and then also made sure that the sealant was pushed down into the crack. On the right-hand side, this was capped over using a sealing disc, and no squeegee was brought back over it. Again, it leaves a little more material on the surface, but this also helps reinforce the edges of the crack and will give you some of the best performance when leaving this open to a traffic. Flush filling is just what it sounds like. We're just going to put the material down into the crack. Generally, you could flush fill it, and then if you have any excess, it could be struck off with a squeegee. These are a good way to install material if you're going to do an overlay or a fine surface treatment where you don't want any bumping or any material coming up through from the cracks. And we got another short little video. this one up and going here. This video here is going to show just a what we would call a blow and go application with a squeegee, no routing. So you'll see the sealant going down right into the crack with a straight tip, and then the squeegee going back over it. And when we do this kind of application, we want to make sure that the lawn operator is getting the sealant right down in the crack and not beside it or close to it, and making the squeegee man have to work that material into the crack. We want to make sure the sealant is initially put right down into the crack, and then the squeegee man squeegeeing it off good and tight. Okay, we'll go on to the next slide here. So our next slide talks a little more about some of the reservoirs that can be done. We've got the standard reservoir. We do see in some areas using a deeper reservoir, maybe going down 3/4 to an inch deep. And then in the colder areas, the reservoir here on the right, where they're going to go a little shallower but wider to allow the sealant to move more. Again, those are used in a colder area where we've got a lot of thermal movements involved. Here's a couple of really good photos of just a good flush fill. As you can see here, the photo on the top left-hand side, this was cut with a saw, then sealed nice and tight. You can see how it gives it a nice clean look. Didn't have to do any squeegeeing or anything over the top of that. And then we can also see that we can do combination configurations where they're going to fill the reservoir and then squeegee it down or cap it off, either with the squeegee or even use a disc over the top. Again, this will get us some of the highest performance because you're getting the material into the routed reservoir, plus you're capping it, which helps reinforce the cracks around the edge of it. Generally, this would be used in an area where you're going to leave it open traffic for possibly a season or a year before you come back and do any kind of sealant or surface treatment over the top of it. And we got another quick video here of a routed reservoir with a sealing disc going over the top of it. Just run in here quick. As you can see here, it's already been cleaned. The operator is just running that disc right over the crack, so it's sealing it. This kind of helps in the keeping, got a small crew, keeping it down to just a couple of guys having to apply the material. You can see it's a nice clean application. Material goes right down into the routed reservoir and then is struck off with the sealing disc, giving it a good clean application and being able to open that to traffic relatively quickly. Okay. Move on to our next slide here. And in our next slide here, I just wanted to show real quick a nice application here. This top photo shows that an area was routed. There was one area up in this top corner here that was a little too close to route, so that was left unrouted. But then it came back with a disc and sealed it all off, and then just made sure they ran over that one crack there that wasn't routed and sealed that off too. So it gives it a very good look, very clean look, very acceptable for this type of application. Of course, we always have some improper applications. Obviously, Tony here was very proud of his work. He signed it. But these are some of the applications that we just don't want to see. It's not doing any good. This picture in the center here, you can see that they really didn't follow any of the cracks, so that it's not doing any good. And then the picture on the far right was just way over application of sealant. Would not be anything we would recommend be done on any roadway, whether you're going to leave it open to traffic or you're going to put a surface treatment under it. There's just way too much sealant there. We do once in a while see some common finishing issues. This top photo, number one, is what we would call sagging. This here just needs to be topped off. It's got a little bit of material on the sides, but they kept the overband good and clean. Just needs to be topped off a little bit. Photo here, number two, we've got a little bit of puddling that ran off to the edge of the roadway. Might have a little bit of slope in that roadway, so the material ran a little. But generally, you can take a squeegee and grab that, pull that right back up onto the main part of the roadway and fix that relatively quickly. Then on number three, probably a little bit more excessive application, dripping, probably more material put down than they really needed to do. But these are some of the finishing issues we do see on projects. Most of these can be easily fixed and maintained and kept at a good quality project. One of the last things I wanted to talk to you quickly is a little bit of traffic control. Especially if you're out on a bigger roadway, you want to make sure that the contractor or the agency is using good traffic control practices, following the FHWA manual on traffic control, and depending on where you're at, setting up the traffic control, whether it's on a highway or a residential area, and making sure you're making your moves within that work zone. The closure close long enough for the sealant to cool and be ready to take on the traffic. A little bit on personnel requirements. Generally, we see crack seal crews, 4 to 5 people working in a crew, depending on what all they're doing. This top photo here, you can see there's a router working ahead of the crew. In the middle, we have another personnel blowing out the cracks and cleaning. And then following up behind that is the truck that's pulling the melter, and crack seal crew behind there, squeegee man and a one man. And then behind them, all the way to the back there, is a trash truck, kind of keeping everybody safe and making sure the vehicles are getting off to the side. A little bit smaller crew here on the bottom one. They've already cleaned out these cracks, so just a couple of guys with squeegees and one man getting material put down. So there are different ways you can configure your crew depending on the size of job that you have. talk a little bit about inspections. You know, we always want to make sure that the equipment is running properly and that the sealant is a proper sealant for the climate and the roadway, and you know, whether it's doing reservoirs or just blowing out the cracks, making sure they're clean and dry, making sure the application temperature is properly set, and we've got good weather to deep cracks. Always there's a little bit of cleanup on a project, making sure that excess sealant spills are cleaned up. We're not leaving any sealant boxes or packaging left over anywhere. All the debris is moved or removed. Some of this could be done with a vacuum at the start, where you don't have to vacuum up or blow out anything afterwards. But if you are using a backpack blower or something to clean off your roadway, make sure you're not blowing it out into traffic or anybody walking on the sidewalks. Then obviously we want to make sure we're keeping it coned off until we're ready to put traffic on it, and then removing all our cones. If you are going to open up the traffic right away, DTAC product can be used on sealant. That'll allow traffic to be put on it right away. If you cannot let it sit and cool for 30 minutes afterwards, then the DTAC product could be used. That generally is just sprayed on out of a Hudson sprayer, and then you're able to open to traffic. Of course, one thing we do see, we see sand used or Portland cement used or lime. They tend to leave extra material on the surface that would have to be gone back and cleaned up. So it's not generally recommended that you use those type of products. And as you can see on this project, toilet paper was used. While it can work, it's not the best way of doing it, and not generally something that we recommend, as it doesn't leave a good look afterwards and will take some time for the toilet paper either to wear off or come off as the traffic gets. We do talk a little bit about, yes.
I'm sorry to interrupt you. There was a question about what kind of detacifiers are used. Is there any kind of product names or?
Well, there's a couple different companies that make detacifiers. Glenn's is one. Crafco makes a DTAC product. Those are the two I know of and see out there the most. But yeah, there are probably about 2 or 3 different companies that make what we would call detacifiers that can be sprayed down.
Thanks.
Then we want to talk here just real quick on resealing. A lot of times we'll see a project that's a few years old and we want to go in and reseal it. This can be done. We always recommend that if there's any loose sealant, that gets pulled out as best as possible. We would not recommend running a router down through there because the router bits will keep that sealant up and it just kind of gums everything up. So the best thing is to see if there's loose sealant that you can pull out, we would pull that out, and then you would want to use heat lamps to run down through there, and that will do a couple of things. It helps remove any debris and get the moisture out, but then it also heats that sealant up, brings a little bit of oil to the surface, and will allow the new sealant to bond to the old sealant. So that would be a couple pointers we would want to see done if you're resealing an older project. Now I want to touch,
Brian,
yes.
Sorry to interrupt you. I had another question about Is there any recommended temperatures for applying crack seal?
Well, recommended temperature, air temperature, pavement temperature would be 40 degrees and rising. Sealant temperature, again, we talked to 380 to 400 degrees, but you always want to make sure on the sealant temperature that you check the manufacturer's recommendation for the sealant that you're using.
Thanks, Brian.
Yep, you bet. Okay, so just real quickly, wanted to touch on crack density. I mentioned it earlier, when you are routing cracks, there is a limitation to when you start routing. If you start to get too much cracking, you will start to do too much damage. So we talked a little bit here about crack density. The general rule of thumb is no more than 20% crack density in an area for routing. Now, talking crack density, basically we're going to take a given area of, say, 100, we talked here, measure out 100 foot of area, and then you're going to have to take time to measure out how many feet of crack you have in that area, and then divide that by the square foot of that area. And that kind of goes along with the same as when you want to try and figure this general crack sealing area and how much material you're going to need. Unfortunately, there's no magic way to figure this. You have to get out and take a given area. This photo here shows, and this is again talking about crack density, but you can figure crack sealant needed also the same way. Take a given area, here's 100 foot by 12 foot long, or 12 foot wide, and they measured out the area, and there's 191 feet of cracks to be routed in this area, which only gave us 16% crack density. So that was a good candidate. You would take that same idea of measuring that area, and you have to figure the width and the depth of the crack, and to figure out how much material you need. There are some crack sealant calculators online. We'll show you that here in just a minute. Or you can kind of do the old math way of doing it and just figuring your depth, your width, and your length of crack. Figure that into cubic inches. Once you have that total of that area in cubic inches, you divide that by 231, which will tell you how many gallons of material you would need in that given area. Once you have that, then all you need to know is the weight of your sealant per gallon. Most sealants will be about 10 pounds per gallon. So then you just times that gallon times 10, and that will give you how much weight of material would be needed to do that. But again, we'll talk here in just a minute where you can go and simplify that with a crack sealant calculator. One of the last things I definitely wanted to talk about is safety hazards. Of course, we're exposed to traffic, exposed to elevated temperature of materials. We've got power equipment. Again, we want to make sure we're always reading the manufacturer's operation guide, safety manuals, and make sure we're following all those. You know, PPE of the past kind of looked like these guys here on the left side, and unfortunately we saw a lot of accidents, a lot of people getting burned. We don't ever want to see people put themselves in that situation, so making sure we've got the proper PPE is very important. Long pants, long sleeve shirt, Heat-resistant gloves, eye protection, hard-soled shoes or boots, safety vests and hard hats. And depending on where you're at, what kind of job you're doing, you may have to check and make sure you have the proper safety vest on. One thing we do want to talk about, if somebody does get burned, you want to make sure you get the area cooled off as quick as possible. Not recommended you apply ice directly to the burned area. You definitely do not want to try and pull the sealant off immediately. While I know it's burning and it hurts, getting it cooled off quickly is the best thing, and then obviously going to the hospital or the doctor's office. You want to definitely tell them what you've been burned by, because generally everybody wants to try and grab it and pull it off, and you're going to do more damage to the skin. You want to use a product that will help dissolve the sealant. Mineral spirits generally will dissolve the sealant off the skin in a couple of days, and that will do the least amount of damage to your skin. We've got short little videos here. We'll play this one. This one actually has a little bit of volume, a little bit of sound to it.
Why I bring it up, Brian, there was a question, is there a maximum temperature for crack sealing?
Generally 400 degrees is the hottest you ever want to run your crack seal material. After that, you start to break down the polymers and the rubbers and the oil, and it would be just too hot.
And I guess I meant more of a temperature on the project, ambient temperature.
Gotcha. Yeah, after you get about into the 90 to 100 degree weather, you're probably going to have to look at changing the type of sealant you're using, because it's probably not going to cool off overnight to where you can put traffic on it. So you want to kind of look at the type of material you're putting down. We have seen crack sealing done in 100 degree plus weather, but again, you want to look at what you're sealing. If it's big wide cracks that aren't moving, you're probably okay. But if you're trying to do small random crack or thermal cracks, probably the wrong time of the year to be doing it, because your cracks are all closed up and you're not really getting material down in that crack like you should. So it's kind of a two-edged sword. You can do it, but really only certain types of cracks should be done that kind of weather.
Thanks.
Doesn't sound like, not sure we're getting any volume on this. Basically, this video is just kind of going over reading your application or your instructions on your melter, safety notifications on your material in that, and then just making sure you're wearing the proper PPE. Again, they're showing that here. The big thing is we just want to make sure everybody's safe when they're out on the road and not setting themselves up to get hurt. And here we're just talking about making sure we're running the material at the right temperature. Okay, I think that's end of that one. We'll finish up with a couple of final thoughts here, and then we'll finish up with the questions that we may have left to hit. Okay. Final thoughts. You know, I know I've talked a little bit about this through the whole thing, but you know, keeping the cracks sealed in your pavement routine will save thousands of dollars and double the sealant life or your pavement life. Cracks that are less than an 1/8 inch wide may not need to be sealed if you have a seal coat or a slurry that's going to go over it. Once you see those cracks growing over an 1/8 inch or larger, those would generally be ones that could be routed again depending on your weather and thermal conditions. And then it's imperative that we want to do the job right with the right sealant, the right temperature, and making sure that we have a good clean and dry surface that we're putting this crack sealant into. If we're not doing those things, then we're just not going to get the performance that we're looking for. We talked about some of the helpful links. Craftco here has a link that will get us to sealant selection. If you look through there, there's also a sealant calculator where you can put your length of your project, the width and depth of your cracks, and it will calculate out how much material is needed. FHWA also has a link in here for a checklist series. PPRA also has the roadresource.org, which is a real good resource for not only crack sealing, but all the other type of surface treatments that you can do. And then, of course, NCPP has their pavement preservation link to a lot of good information there also. So, make sure you look at these. It's a lot of good information, and it could be very helpful for you. So, Jason, let's finish up with any questions we have left.
I'm sorry. Brian, let's turn it over to the next slide and have Ann mention the next webinar, and then we'll come back to questions.
Oh, okay. Yeah, we'll move on here to Ann to talk about our next webinar.
Thanks, and thank you, Brian, for today's presentation. Our next webinar in the series will be held on April 15th at 2 p.m. Eastern Time, and will focus on the use of RAP in pavement preservation treatment, presented by Greg Duncan. To learn more and register, please visit roadresource.org. With that, we'll pass it back over to you, Jason and Brian.
Thank you.
Thank you, Ann. And Brian, it looks like we're getting close to our time of wrapping up. So we have a few questions here, and if we don't get to them before they close shop here, we'll put it in the email as we send it out with the presentation today, the PDF, and et cetera. But do you have an equivalent crack density percentage for use in metric, Brian?
I don't know that we have one set up in a metric, but we could definitely take your same type of measurements and just move that over to metric, and that would give you the same, obviously different numbers, just in the metric numbers.
Okay, thank you. We have another one is, what is the optimum range to crack seal to best fill the cracks? Is there an optimum temperature range?
But generally, we say to either in the spring or the fall, when your temperature starts to cool off, maybe not at its coldest temperature, but not at its hottest temperature. That way the asphalt is relaxed and your cracks are starting to open up. May not be open all the way, but they're starting to open up. That is generally what we would say the best time to get in and do your crack sealing. So spring and fall for your area, for all the areas, is what we would generally try and say. I don't know that we've got an exact number on it because our temperatures vary so much across the country.
Thank you, Brian. And it looks like that's going to be the end of our time period. And I just want to say thank you, Brian, for your time and your commitment for today's webinar. And I turn it over to you to any last final comments or thoughts.
I appreciate it, Jason. I thank everybody for joining us today. My card is here. Feel free to reach out to me if you've got any other questions, or if we can help you in any way, we'd definitely be happy to help you. Thanks again for everybody sitting in with us today.
Everybody